This is my second time speaking at the Cassandra conference. I've been here for about 3 years, and I'm here to talk about some of our experiences with Cassandra and how we push some of its boundaries pretty bad. So this is a rough plan that I plan to talk about. Obviously, the introduction, who we are, what we do, what we build as a product. I think it'll be pretty clear by the end of this, we are one of the few unique players trying to utilize Cassandra, because pretty much everybody is trying to run a hosted service as opposed to we who ship Cassandra as part of a shrink wrap product. We'll talk about our journey of Cassandra and all the metrics along the way in terms of how we evolved, what projects we scrapped, what projects got successful, why they got successful, stuff like that. Our challenges of big data and the whole spectrum of it as we go along. Some of the pivots that allowed us to use Cassandra effectively for some of our customers, which are some of the largest scale telcos. And finally, I'll show some metric about what the year-over-year change is for a single Cassandra node. And I think it gets lost in translation when people talk about 35,000 operations or 50,000 operations, but talking about a single box, a bare metal box, how effective it has become over a year. Some insights and some learnings that we had along the way, and finally conclusion. Okay. So first, who we are. We are Openwave Messaging. We have global tier 1 customers around the world. If you think of telcos around the world, there are probably like 25 world telcos, the big guys. There are probably 4 or 5 in North America. Every continent would probably have 4 or 5 of them. So the spectrum is not that big, but each one of them is pretty big. And there's a reason why when we talk about appliances or products, everything gets certified at telco scale, because they're pretty abusive with all the products. Some key metrics. Our average deployment is roughly 6 million subscribers for a platform, and the largest is actually 28 million. So reasonably big size is how you would like to call it. And the use cases are the boring email to SMS to MMS to voicemail and whatnot. And on the face of it, it sounds pretty interesting because somebody said on TechCrunch, 2012 was the year of peak SMS. SMS is getting slaughtered because of iMessage and WhatsApp and whatnot. And the reality is that if you go around the globe, the messaging space is very fragmented. So we'll shed a little bit of light on that. Most of these guys have been our customers for about 8+ years through a very interesting transition, and a lot of them are actually upgrading to Cassandra. Some of them are already live on Cassandra. This is what we build. This is our product in a nutshell. And the key is that we have been using, or should I say abusing, databases for a long while, right? Pretty much every database that you can think of, or every credible database in the last 10 years, we have tried to hammer in a nutshell. Everybody who has a data plan with AT&T, every 500 milliseconds, is making a dip in our Berkeley DB instance. It's been up with 5 nines for the last 5 years through multiple upgrades. It's a simple directory product, but it's a pretty freaking achievement. You don't see ever that your data plan stops working, for example. And the amount of applications have grown. At the heart of what we build is essentially the message store. And we came up with this geo-redundant message store across geographical redundancies, mainly to answer some of the issues that came up with Japan tsunami. People in Japan especially are very paranoid about failures. They literally do not want to fail, even when a data center goes down. And the market started asking us, we need to build a geo-redundant solution at a significantly cheaper price. There are obvious solutions out there in the market with clustering and all that stuff, which we didn't want to go to. So that's when we decided to go with Cassandra. And the upper part is what we call the protocol stacks. The typical IMAP pop is dying and whatnot, but pretty much your iPhones work with IMAP today, or ActiveSync, or what your protocol of choice is. That's exploding to the roof. The notification and queuing is going to the roof. And these systems, once you start looking at scale, especially for the footprint that we work with, are pretty abusive, meaning we're talking of 50,000 transactions per second for a few hundred boxes, not like thousands of boxes, like the internet companies, right? So we really build very dense applications. One thing to also highlight is that we are not so much of a, if you will, a UI company, meaning we partner with some of our partners to build like a typical email application and UI, but we don't build our own. We have them interface on top of our message store behind the hood. And at the very left of the spectrum, you have the typical, the key value pair kind of stores, the traditional things that telcos have been using for quite some time, like LDAP and stuff, evolving to all the other side where you have really unstructured data like blobs, media, content, what be it. And Cassandra sits right there in the middle. And what we allowed is to build like an application level geo-redundancy, meaning any component above the message store doesn't care about geo-redundancy. It doesn't know, in fact, about geo-redundancy. And this is an amazing spectrum. There are customers who are taking this solution and trying to build it within one data center for geo-redundancy, simulating WAN deployments. There are people who are trying to actually take it and build it in a service continuity model, meaning don't try to do full geo-redundancy, it's too expensive, but try to build as you go along kind of model. So people are trying and experimenting this very interestingly. This is what we built. This is an interesting sort of graph, if you will. Colors look very interesting on the slide, but either way, we started actually in 2009, late 2009, trying to use Cassandra. Okay. If you go to the GitHub repository, the file names have the word incubating in them. That's how early we started using Cassandra. There were probably 20 employees of Cassandra data stacks at that point in time. We spent almost a year before customers actually started saying, let's try this thing out, right? Is it working? Is it not working? Stuff like that. And this is very unique to us. I must say we are the early adopters of Cassandra, but also that our customers are not, we can't just try something out and go live. We basically have to go through a huge life cycle of certification through telcos, and they don't like to go live very quickly. So they'll abuse it very heavily, and only then they will go live. So we started having some ramp up in Q4 of 2011 with trials, literally in labs and stuff. And these trials are real trials. I mean, some of the trial infrastructures is millions of dollars. Like just the lab is millions of dollars. They actually put high-priced SSDs, the real thing that goes live. They actually put the whole scale in their labs. And then late Q4 2012 is when customers really started to go live, and there was a huge hockey stick growth over there. And after Q2 2013 is kind of the projected trials and going live. As you can see, it's roughly a 2-quarter lag, that trials and going live lag. But if you look at it as a percentage of the Openwave subscriber base, and I can tell you this is about 100 million subscribers across all these telcos. It's 100 million users across these telcos. We are expecting that a year from now, we will have 60% of subscribers being powered by Cassandra. So that's a pretty powerful statement for justification of Cassandra as a backend technology. But there's one more interesting element that I wanted to show, which people don't see, which is kind of the inside story. So although we started, the first year the project was scrapped. Multiple reasons, but part of the reason was we didn't really understand Cassandra as well. Okay, we didn't truly understand what eventually consistency was. Either we got too sold on the eventual consistency model, or we didn't understand it, or we used some of the early constructs of Cassandra which were not ideal. So there was some kind of shaking off that happened. In Q2 is when we really had sort of a first GA release that we kind of launched out in the market with. Obviously, it takes a lot of time for telcos to, oh wow, these guys have something new. They won't change if something is new. It really have to prove them the metal for it. last year, roughly this year, we changed ownership of the company. We became a private messaging focused company. We're no longer part of a big group, separate investment, everything. And I especially would like to talk about that customer emergency that happened 2 quarters ago, and kind of cemented the notion of Cassandra for us, like why it is so useful. And finally, just about, I think I'll hear it very soon, but one of the largest telcos in the world, and I'm unfortunately not allowed to speak their name because they don't allow us to do that, but I can only say it's in the news right now trying to talk about some merger in North America. Let's just say that. The largest telco is about to complete deployment for 20 plus million subscribers on Cassandra, a single installation, right? So that's a pretty freaking big deal. And these guys drive us nuts, by the way. I mean, they really drive you nuts. They ask you about 10 millisecond going here and 20 millisecond going there. So they are very smart technical folks. They actually tell our sales guys and professional services guys, we need to talk to the engineers. We don't want to talk to you before we sign the check. It's pretty straightforward, right? So they are very hardcore, hard metal, and for them to actually go live is a pretty big deal. So I wanted to talk about this interesting thing that happened last year. So we are kind of preparing, this telco is preparing to go live, and last year, as I said, there are lots of people who are trying out in the labs for about 2 quarters. There was this one customer in North America, again, I'm not allowed to take their name, but they are our customers of ours. They're using our previous generation product, which uses a traditional EMC array of disks and whatnot. They use an Oracle database, they use all of this stuff. It's been humming along for 7 years. They have no incentive to upgrade, nothing. They wanted to try out our new product. So they had a small system running in the lab, and they were trying it out. Not so big. About 1 million users, give or take. And in December, there was a file system corruption. And as you have it, the backups themselves were corrupted. So there was no way to recover some of these things, right? So what the brilliant idea that came along was that why don't we take the lab system and put it live? Like, okay, let's put it live, except for 2 years, they have been, these machines were not upgraded, their firmwares were not upgraded for 2 years, like really bad stuff. Nobody had paid attention to this lab that was running. So I'll spare you the details of spending 3 a.m. morning calls and whatnot, but we went through we took this Cassandra system, we put it live, meaning users who didn't have mail access started getting mail, and then we had to kind of migrate over their old mail, put it into their system behind the hood while the system is live all the time, right? And the system is, I wanted to put there sort of an undersized system, if you will, because as I said, our early understandings of Cassandra were pretty premature, and the system was sized for that. But by the time we actually went live, the sizing was iffy, if you will. So we had to learn as you go along on a production system. So this was an interesting metric. We realized, first of all, that there's not enough RAM in the system. And this is like a 7 to 10 node Cassandra ring that we are playing with. And we realized, well, first of all, Dell says that some firmware has to be upgraded. Okay, we need to bring a machine down, upgrade the firmware, bring it back up. Fine, so we did the firmware upgrade. Then we need to change the memory. Oh, the memory is running low. Okay, fine, we need to add the memory, stuff like that. What I found most interesting was that it took us roughly 20 minutes to bring a node down, put a RAM back in, put a node back up, nothing. I mean, like the system just kept on running, literally, not a single error, right? Now, you can hire a lot of, how should I say, the technical consultants of the big guys like EMCs and Symantec's and whatnot, but this was pretty dumb. I mean, all we really had to do was follow a bunch of steps. We could give it to someone who had never worked with Cassandra before, so we had to literally dumb it down in a script or a FAQ guide. But he could bring the machine down, take it off the rack, put a chip in, put it back up, power it back up, boom, it joins the ring, everything gets settled back, hinted handoffs, we see the spike of activity, tapers down, done, right? And I think that is an amazing statement to see it really under fire, right? Because this is while customers are basically slamming the customer support call saying, my contracts are in my mail and I'm not able to get hold of that. I mean, this is pretty big stuff, right? It's, I joke about this, but we kind of build things which are commoditized. You don't think about your email never being available. You never think like that. It's always available, right? So to see Cassandra actually work after that was pretty good. There was what I call, I'll talk about this, eventual consistency, fallacies in many ways. But, there's a price that you pay for eventual consistency, which is you don't pay now, but you pay later. And that we had to solve by putting more IOPS, which is SSDs. But the same thing, we could actually order SSDs. We could calculate roughly that it'll take us 7 days before we will totally blow away the Cassandra cluster. Got the SSDs in, bring the machine down, put SSDs back in, put it back up. All the while system is running. And I think that was a huge statement for us and a turning point for a lot of our customers that, it suffered a calamity and it actually worked. And by the way, this is a very dense footprint, meaning this wasn't like a really big system. We're talking of tens of boxes. We're not talking of hundreds of boxes for millions of users. So this is, without going into much detail, but really this is the spectrum of our big data challenges, right? So if you think at email, first of all, everybody has infinite expectations. Email just keeps on growing. Nobody deletes mail, ever, pretty much, because Gmail spoiled all of us. So we never delete mail. We use email for multiple purposes. At the very kind of left end of the spectrum, you have account data, which is your accounts and stuff. The thing that, as I said, if you have a data plan, it needs to check every so often, do you have enough capacity left or not, which is okay, but mostly provisioning. There isn't much of, there's some writes, but not very heavy writes. In the middle is what we call is our Achilles heel. It's our metadata of our message store. And the interesting part is that metadata it has a whole spectrum of, it's easy to solve a problem if you have all messages of 140 characters, but if you have a message which is of 10 megabyte and at the same time you have a SMS message which is literally 100 bytes, you need to solve that entire spectrum. So that metadata is for that. And then there is the content, which is, I didn't want to call it messages, but really content, because people are using photos and everything is getting uploaded right there, right? So on this end, you really have CRUD operations, create, read, update, delete, really heavy create, read, update, delete. And the more important parts are the updates and the deletes, which Cassandra, you really need to understand well Cassandra's internals to optimize for those two operations. And most important is the counters, actually. For email, especially for IMAP as a protocol, there are very strong connotations of counters. And counters represent time series in many ways. So if you screw up some counter in the IMAP protocol, your iPhone will not be able to get mail, or it will get totally screwed up, right? So it'll try to re-download the entire mail. You will never get out of it with a really large mailbox. So you cannot mess up with that, okay? The CRUD, the blob part, is really, it keeps on growing, almost never gets updated, maybe gets deleted sometimes, but people are stopping doing that more often. But really, it gets archived after a while. So you cannot throw infinite amount of SSDs there, so you have to use cheap quality disks, and you have to worry about how do you archive those kind of blob sizes. But more importantly, across both these spectrum of data challenges, we have to worry about geo-redundancy. So all of this entiered geo-redundancy, meaning I can say I need my account data and metadata to be totally geo-redundant, but my blob data to be not geo-redundant, right? So I need those kind of toggles. Obviously, the reliability, you can't mess up with some of this data. If you mess up this data, you have a problem. And you really cannot talk about downtime. There are some folks, some of our customers in Japan, they want to store 5 copies of data. They go wild, actually. They say, Cassandra can do so many copies of data, let's just do 5 copies. But that's how it is. This is the spectrum. And these are some of the pivots for Cassandra that, and I'll spare all the details. There are lots of technical details that go below the hood in terms of Cassandra. But for us, these were some of the driving points. One of the important things is JBOD. I'll show you how our footprint has changed on a single Cassandra node. And this was our biggest problem last year, which is you deploy this and you have a bunch of disks, and if a Cassandra node goes down or a disk goes down, it thinks the whole node is down, and when disk comes back up, it tries to resync the whole thing, and that actually creates a bigger problem because it brings the whole ring down in many ways for our kind of footprints. So JBOD was a huge help. For counters, we tried to solve using atomic batches and application level affinity. And I intentionally have a dotted line over there is because you need to understand. There's no free lunch with regards to isolation of asset. Cassandra will never implement locking, pretty much. As we heard Jonathan say today, they will never, ever, ever. It's fundamentally not designed for locking. So this was the first trajectory to give us this atomic batches, and I'll explain how much big of a change this was for us. From a reliability perspective, obviously the replication factor and all that is good. You just store multiple copies of data. But I think the tiered knobs via consistency level was interesting because distributed systems go down all the time. Networks have hiccups all the time. So having this mechanism where you can say, this data I'm okay to get a wrong copy of data, but this one I want to be absolutely sure I cannot mess up with the counter data, for example, right? From a schema perspective, really we're talking of the flexible ordering, meaning you have the natural ordering of things in terms of how you order and sort and stuff, and then you want to have this arbitrary size rows, and there are enough articles about the data model. How do you go about data modeling and denormalization being your friend? But really the idea that you can actually have arbitrary size rows is a powerful element for us, because if you think about it, Gmail doesn't care, or any mail application doesn't care how many messages you have in your inbox. It always renders below a second, and that's the metric that we need to that we are shooting for. Most of these telcos want that infinite storage, but we want to meet that instant user latency. So these are kind of keywords for us, and as I said, there are lots of details that go below, but spare that for later. This is atomic batches as it boiled down to a nutshell. And for folks who understand distributed system, this is no-brainer. If you have ever built your own server or your own client, you do some of these things yourself. So in Cassandra 1.1, anytime you wanted to make a change, you would usually, hey, get a connection, do some change, free the connection, get a connection, do some change, free the connection. This is what you would do. This is what our code used to do earlier on. And by the way, just wanted to mention one more thing. Because we have been using Cassandra since it was 0.4, we are using Thrift even today. So we actually use Thrift in a C++ world. We don't use the multiple libraries out there. So we pretty much care about the bits and bytes that go on the wire. That's one of the reasons why we care about some of these details. So this was the flow. You could do an application optimization to avoid contention on your client side by doing like get connection and then fire 3-4 queries. But if you look at all of these, there are still a lot of round trips going back and forth from Cassandra. And this is important because, on one side, Cassandra, you need to understand that denormalization is your friend, meaning you maintain secondary indexes, you copy multiple copies of data. But then, what if something goes wrong? And the answer that we used to get for the last 3 years was that most of the time, most of the things don't fail. But in our world, people always ask the question, but what if when they fail? Right? And for us, so that we kept on pushing for these atomic batches for 2 years, and then finally we got it last year. And essentially it's pretty simple as that. You do all your batch, and it's an all or nothing batch from a database perspective. And although from an IOPS on the back end, it's exactly the same. I mean, in the number of operations, it may even be a little higher, but the sheer reason that the application doesn't need to worry about it improves the overall system footprint, because your contention on the client side goes down, the number of resources required by Cassandra goes down, which helps us garbage collection and all of that. But the beauty is that this allowed us to do something very fundamental with our schema, which is now we don't need to worry about managing failure conditions, but the backend does. And the backend guarantees that it's all or nothing. And I consider this as a trajectory towards transactions, the eventual transactions that RDBMS used to provide, lock and update, and it's all or nothing kind of model. So we got atomic batches, and today Jonathan talked about compare and set, which is kind of the next step in terms of getting there. So these technologies are kind of converging over a while. They will never implement locking, but we have got enough. So you get atomic batches, you get compare and set. Those are good enough for the operations that you care about. the kind of operations that you care about. And we do really care about these. I mean, these are bank level counters. We cannot mess these counters. Our customers, so we used to ask them, what if we allow you to go above your mailbox quota by like, 5% or 1%, and then do eventual cleanup of that? And they say, no. We want you to guarantee that somebody can never abuse a quota on a single message deposit. And the only way to do that is to have very accurate counters. So it's literally like a bank. You cannot withdraw more than the amount of money you have in a bank. So it's that level of consistency that we deal with. So this is, all said and done. At the end of the day, we fight on footprint. These are one of the key metrics for these telcos because they care about heating and cooling and all of this stuff. So how many boxes do we use, right? So these three things, so Cassandra gave us atomic batches and JBOD, right? We utilized those concepts and some couple of folks are sitting here and basically understood how Cassandra lays column family on a rotational disk, meaning how can you minimize random seeks on a disk and actually lay out sequentially so that you find something and you seek it rather than doing random lookups. So you need to understand that level of detail. And then we build a application level affinity to guarantee these counters, meaning guaranteeing that within the whole system, there's only one guy who's doing something, right? So basically achieve serialization. So these three things combined give us something like this. Our metadata, again, I'm talking of a single box. It's very important to talk of a single box because you can play games with numbers, but with a single box, it's pretty clear. So in 2012, we had a typical single box for a metadata with a 300 gig SSD. That was big, but it was not big, right? We basically moved to roughly 12 900 gig 10K SAS drives. This is big because now you're suddenly pretty much going to like 12 terabytes of data per box. And by the way, this is metadata. This is not the blob, right? The blobs are massive, actually. I'm not going to go into the memory and CPU. They basically remain the same for most parts, right? The blob stuff, in 2012, we used to have like a 10 terabyte blob in many ways. Well, our meta is now almost close to that in many ways. And we basically improved that blob storage by 4 times. And here is the kicker. This is a medium scale deployment. This isn't a large scale deployment that we plan to go live. This is really in the mid-range, if you will. So if I didn't say enough, we go with really dense deployments. I mean, a single box really holds a lot for us. So now you can see, without JBOD, we cannot put 12 900 gig 10K SAS drives because a single disk going down on a 40 machine system, you're talking of a disk going down every day. Pretty much by mean time between failure, a disk will go back every day, right? So you cannot afford this notion of the machines recovering all the time just because a disk is down. And the blobs, actually, we try with Cassandra. We also try with some other vendors, like S3 vendors, that we use, which are optimized for this object store. And there are things in Cassandra that do not allow us to use Cassandra for blob stores at this scale. Some of it are, how does it do replication, storing exactly 3 copies of data. There are people who are optimizing that logic further and saying, if I have a 10 megabyte object, I don't want to store 3 copies. I want to store some parity information as opposed to storing 3 10 megabyte copies of data. So you start trading off reliability for space and cost. But this all is nice and good. So this allows us to do that. And so it's 36x meta storage increase. And I didn't put the IOPS because it gets very interesting. If you think about it, that one 300 gig SSD has probably more IOPS than those 12 900 gig combined. But the fact that there are 12 gives us that parallelization of IOPS. It's in a single box, right? So we increased the meta storage. I think we decreased the IOPS storage. There's some debate internally. And we did increase the blob storage significantly. But we did and this is hot off the press, but this is a more important number, right? So you keep on pressing the needle with regards to capacity within a box, but you achieved a per node savings. If you do a apples to apples comparison in terms of protocols or applications, it's the same test suite, and you try to run on our 1 year ago platform and you try to run on this year's platform, we actually achieve about 40 to 60% IOPS savings overall. And the reason for that is you do really need to understand three things, which is atomic batches, how they work fundamentally. It's not just, our engineers who are sitting here, they don't just, if Jonathan says, oh yeah, we have atomic batches, the first thing they'll say is, show me the Java code. I have to go inside and look at it. How exactly is it implemented? Is it efficient enough or not, right? So you have to understand that. But then you need to understand how the column families are laid off, how do you order the column families, and how they actually get laid off on the disk, which is a more important aspect. And we did have to do a major refactoring of our schema. Our schema doesn't look anywhere close to what it was a year ago, and add our application level kind of affinity. Now, some of these things are pretty strong and pretty unique to our position because we build a product and give it to telcos which can never ever fail. There are people who don't do this. Netflix uses a much different model than what we use because they can afford to lose some data and people won't cry out loud. If your pause on a video is lost, it's not end of the world. But if your mail is lost, that's considered pretty bad in many ways. So these are some insights. I have two shares of insights, and the first one is just general, but the second one is really a couple of technical points. So first of all, it's a new paradigm. It will take time and investment. No matter what anybody says, it's going to take time and investment. So it takes time to unlearn the old stuff and learn the new things. It won't take as much time and investment as some of the early adopters did, but it does take time and investment with regards to making it really production quality, right? And I'm not talking of putting something, trying something out, and then trying something else out and trying something else out, but really maturing it takes time and energy. It's funny, especially people who are distributed system engineers, they understand that there is no free lunch, but we keep on hearing these buzzwords come out again and again. The cool features, and some of the cool features that I talk about, atomic batches have a price. There's a cost that the Cassandra database has to pay to achieve atomic batches. There's a cost that Cassandra has to pay to do compare and set, and we need to understand that cost rather than fighting it. Especially, as I said, some of our Japanese customers, we had to literally show them that as you increase the number of copies, how does the throughput of Cassandra ring go down? So we have to actually show them, even though you do asynchronous replication, it's about not paying right now, but paying later, in a nutshell. The sizing for a Cassandra ring, other than all the tuning, once you have gone through all the tuning and all of that exercise, it's all really boils down to IOPS, assuming for persistent storage at least for now. But not all IOPS are equal. You have to understand the size of the IOP, the rate at which you are writing, the rate at which you are reading, how it can stop or change some of those things. As I said, you really have to understand the difference between a random and a sequential seek, as with many of these things. Eventual consistency is a dual-edged sword. I like to compare. The best comparison is credit card debt. You don't pay now, you pay later. And if you don't pay attention to it, it will have runaway consequences. For example, in the case of the emergency that we had in 2012, this customer didn't have enough IOPS to ever catch up. They will never catch up. Literally. It was just a bunch of hard disks with less amount of IOPS, and they didn't plan for SSDs. And they were fighting, executives were fighting over should we use SSD or should we not use SSD, costing $12,000 or something of that sort. And every single day that we lost, we were that much more closer to the cliff. Because after that, no matter whether you buy whatever amount of hardware, you will never recoup and you'll have a system outage. So tuning that is one of the key things. And if you think about it, in some sense, for email at least, when we saw our earlier messaging platform, trash can is the ultimate eventual consistency in mail. If you think about it, when you delete a mail, it goes into trash, and then eventually you clean up the trash after 30 days or 40 days or whatnot. And that works perfectly fine for transactional systems, but for a Cassandra-like system where every transaction is eventually consistent, you do need to pay that price every so often, meaning nightly. There are people who want to do it every 6 hours or 8 hours or whatnot, and really depends on how often you want to do it. And the last one is an interesting one. Every single thing that I have seen in the last 3 years with Cassandra, we have tried to do ourselves first. partly because we were the early adopters. So for example, when Cassandra didn't have compression, we implemented our own application level compression, and then Cassandra came up with snappy compression. We implemented our own sort of this illusion of atomic batches at the client level before atomic batches came along in the back. We implemented our own application level affinity before compare and set came. So we are kind of adapting that, but if you look at it, it has reached a point where those adaptations, if they work for a telco scale, they probably will work for most other use cases, right? So you really need to adapt those paradigms, and don't try to, last year I was fighting this with Jonathan, and I said, look, I have this counter problem, what do I do? And he kept on giving me these different options, and in the very end, this is what Jonathan said, use MySQL for counters, right? Because the compare and set was not there, and we had to say, throw a 100 gig SSD on a MySQL, store counters there, store everything else in Cassandra, and try to make them coexist. But now you get to the other problem. How do you achieve consistency across these two databases, right? So you just exploded that problem even further than before. So lucky we didn't go down that route, and finally we have compare and set, which will help us a lot. These are some technical insights. Many of these I shared at last year's talk, and you guys can look at it. But I'll just walk through a few of those which were standouts for us. So the first part is the replication factor. Most lab systems don't have, you can easily create a bunch of nodes on AWS, but as it's pretty clear, we cannot run anything like what we run on any cloud out there. AWS came up with SSDs last year. We have been running with SSDs for 4 years. Right? So, by the way, and we run with pretty much every hardware vendor that you see out there, Fusion IO, Violin Memory, any of these guys, they really want us to test their hardware, because that's the best way to, it's so close, it's so dense, that if you can prove at that level, they basically certify it for everybody else, right? So we had this interesting issue where we had a 5 to 7 node Cassandra ring, and we kept on hammering it as much as possible. And what we realized is that at some point, we kept on increasing the number of application instances that are hammering the Cassandra ring, but the TPS that we get as an entire cluster was essentially same. It never changed. And it was a shocker. Is there a network bottleneck? Is there, what's going on? And this is where a lot of those things come together, which is, even though you're paying asynchronously for your replication, you're still paying for the IOPS on the back. Those nodes have to do IOPS at the end. And the only way your throughput will really increase is the ratio of RF to the ring size grows dramatic. Meaning, if you're storing 3 copies of data, right? And if you have a 30 node ring size, you will see close to linear throughput growth, right? But if you have a 3 node, if you have a replication factor of 3, and if you have a 4 node Cassandra ring, forget about it. It's not going to go linearly, right? You are basically saturating the ring at that point in time, or close to saturation, right? So that was the first thing. The tombstones, it's amazing that Jonathan brought it up today in the keynote. You see what happens with tombstones. We have been dealing with this for 2 years now. Some of our biggest telcos are actually doing exactly this. They store the message in our platform. Within less than 2 seconds, they get deleted, because they get delivered to the device and you're done. It's not stored on the server. And you see this massive array of tombstones grow up. And if you don't clean them up, if you don't set the GC grace seconds to be not the default value, which is 10 days, and something more reasonable like a day or less than that, then you will have these tombstones pile up. And if you don't clean them up, then you will have runaway compaction issues or maintenance issues. This sizing was you need to plan for the perfect storm in Cassandra. So you have this maintenance going on in Cassandra. At that point of time, a bunch of failures have happened, which means all these nodes are taking on the load for all the rest of the ring. But at that same point in time, some other nodes join the ring. And it's the funny thing, but during that short period of time, there's actually a spike of activity, right? Just purely because the ring is readjusting and rebalancing. So it's actually, if you size just the raw load plus whatever replication is going through, that's actually the normal load. You need to size for that. Plus you need to size for compaction, plus you need to size for recovery. So it's actually a 3x sizing. And you need to be careful with regards to sizing some of these things. Counters, I already said. Super columns, they're going to deprecate. Thank God for that. It's good. Please don't use super columns as much as possible. We use them. We will probably never ever get rid of them because our schemas cannot be changed as so often because of our customers. Don't use super columns. They are evil in many ways. And the client interaction, this is what I was talking about, connection management and all of that stuff. There are actually issues where you get this thundering herd syndrome on the client, because you are contending on the client. You have not tuned your number of connections and threads and all that on the client side. You are contending on the pool. You are sending more transactions to the backend. The backend is backloaded because of GC or whatnot. That translates into higher latencies, which exacerbates your contention problem, and then you have a piling up problem on your application. So it takes a long while to clean up that syndrome. It really takes a long while, frankly. I hope that async protocol that Jonathan talked about might solve some of this, but need to be aware of this, that if you don't tune your backend will have GCs. It's a Java system. It's not, whatever you do, there will be some garbage collection. There will be periodic unpredictableness of your latency, and because of which you could have contention on your client side. So in retrospection, so we are playing the game of messaging. And messaging is kind of this broad spectrum. If you go and search on TechCrunch for messaging, you will see this space is actually, for some apparent reason, very hot. Sparrow was bought by Dropbox, and Mailbox was bought by Dropbox. Sparrow was bought by Google. There's a lot of thing happening on the UI side, because email is non-functional as it stands today in many ways, right? We are abusing email. We play in this space everything but the real-time collaboration, right? So we don't do real-time video chat. We don't do any real-time stuff, not yet. There are cross-pollination opportunities between near real-time and real-time, but we don't play in that space. The audience is really consumer served by tier 1 service providers. These guys are, and the funny thing is, because we are global, we have North America, significant North America footprint, APAC footprint, and Europe footprint. The consumers over there have very different cultural semantics. You can't just change, it's very different. For example, we think of iMessage and WhatsApp as the best thing that has happened to us in North America. In Japan, it's a line or whatever be it, that is the cool thing out there, right? So it's a cultural thing. People still think Yahoo is an amazing search engine in Japan. Yahoo Japan is still popular. The rules that we play with is TCO per feature, total cost of ownership. It's not just the footprint, it's not just the, it's CapEx plus OpEx. We have to worry about, is the guy who's going to run the Cassandra ring smart enough? What is the amount of training that we need to invest in it? How can we dumb down some of these things? That's why making Cassandra easy to use, as Jonathan says, is very important, because that brings down the TCO per feature, and that's an important aspect. For example, we implement our own what we call hierarchical storage. If as mails get old, we put them to lower cost machines, larger Cassandra rings, but lower cost machines, which have archival characteristics. They are not transactional characteristics. Geo-redundancy, obviously, because believe me, after the Japan tsunami, nobody wants to bear with any kind of downtime. They showed us a graph of one of the biggest telcos in Japan, and I worked at Yahoo, and I can tell you, the telcos in Japan, they actually put out notices before 24th December telling consumers, please stop using messaging. Please stop for a while. Literally, they tell people not to use messaging, because even if they get it down by 10%, that's a huge savings for them. And I think Cassandra, given our history for this long, has worked out to be a pretty good gear to allow us to win at this game. And we are starting to see that adoption trickle down, and we are starting to see some of the most hardest people getting convinced with regards to the feasibility of Cassandra as a backend. They still have a whole array of lists. I always have a running list which I keep on sharing with Jonathan. I shared a huge list in 2011, and pretty much a lot of these got solved. I have another 10 things that I wanted to solve with regards to backup and encryption and all that stuff. But these guys really care about telco grade software, right? So, but seeing that it's actually getting adopted at some of these things is an amazing, amazing statement. And finally, I just wanted to show, you get the typical pitch of, oh, we are hiring kind of model, but I didn't want to do that. So these are some of the challenges that we are working on right now. Okay, migrations. I don't want to talk about the exact semantics, but everybody sitting in this room has an account with that email provider, and we are going to migrate off that email provider to our system, okay, for a big telco in Europe, really big telco. And we're going to migrate a 10 gig link, migrating 6,000 messages per second, constant for 4 months, constant, while the actual traffic ramps up with 0 failures. That's the goal. That's the challenge we're working on. From a scale perspective, everybody's wanting to go to infinite storage, but the key is you need to go with sub-second latency for all types of content, right? So you can solve the problem for a 160 byte message, but what do you do for relatively larger messages? Where do you do streaming? Where are your contentions? Those kinds of problems. We are working on APIs. I didn't even go into detail of our core strategy, which is opening up the telco infrastructure. Because if you think about it, telcos are the best possible platforms out there, right? And messaging is just one component of it, but really, I mean, you see sign-in using Facebook everywhere. Why don't you see sign-in using Bank of America or AT&T? I mean, there's nothing about AT&T that would you rather trust your credentials to Facebook or to AT&T from a security perspective as a consumer? I mean, no-brainer. And finally, with those APIs, we hope to create a platform as a service through these telcos, but with infrastructure as a service TCO. Meaning, think about AWS kind of scale or footprint and optimizations, but trying to open up this platform. And finally, just think about it. We have these stories of these mailbox being bought over or whatever with 1 million users, right? How would somebody like in Silicon Valley to get access to these 100+ million users through a single open API without caring across a global base? That's the problem that we try to solve. So thanks. If you have any questions, I can take some. Yes, not?
It seems that you package Cassandra as part of your product you ship to telcos.
Yes.
Does the telco operate the box, or you help them, or you support them?
So they operate the box, and we build tools around it to kind of, they really don't care that it's Cassandra. I mean, they know that it's Cassandra. They want to know what exactly is under the hood, but from all practical purposes, it's our appliance.
So do they build new applications on top of your box, or you have to do it for them?
So we are opening up our platform. So we give them simple REST JSON APIs, and they just work off that. They don't care there is Cassandra or Oracle or whatever behind the hood.
Obviously, you have these user tools still, so you put the time down on those tools to get the doesn't that give you lots of problems with repairs? How do you deal with repairs following failures?
Yeah, so that's a trade-off that you need to make. So you can only use it for use cases where the lifespan of an object is pretty small, right? So you are taking a chance that, so when we write, we ensure that we won't have issues with repair. So for example, we could write with quorum on a single data center or local quorum across data centers, guarantee that it's written pretty much, and then afford to reduce that timestamp to a small window of time.
But if you use a node, you still got a
Yeah, but again, you're playing with a game of probability here, right? So if you have passed 10 seconds, 10 seconds is the maximum lifespan of this object in many ways, right? So if you have guaranteed to return it, an object has to, multiple machines, multiple failures have to occur in that 10-second time so that you cannot recover. So it's a interesting tuning exercise that you need to take care. Yeah, deletes are bad in eventual consistency.
For those scenarios, you typically run like noticeable repair like once a day or any number of hours?
Yeah, so we as I was just explaining, there are people who are trying to even run it like multiple times during the day, if possible. And last year when the emergency happened, that's when we really learned, and we basically ran, I don't remember the exact sequence, but the repair, compaction, repair kind of trio multiple times during the day, just to get it all kind of stabilized during that crisis period. But it really depends on how much IOPS you have, because this is pretty heavy on IOPS, and it's very tricky because you want to do it during an off-peak hour, but the off-peak notion is going away for our applications. We literally deploy a Cassandra ring across the 2 data centers, which are 3 hours apart in North America for one of our biggest customers, 20 plus million users. And it's amazing because these guys start compaction and running maintenance and all that on this side of the ring. By the time it's actually peak on the other side. So it's a very interesting exercise to actually balance those two.
I mean, this might be too early given for telco, but do you guys deploy Cassandra 1.2 at all?
Starting to. That's what we are, this year's deployments will be on 1.2. Before end of the year, we'll have a 1.2
The
deployment.
reason why I ask is they have the tombstone threshold and the tombstone interval.
Yeah.
Basically, which are part of 1.2 that you can tweak the ratios,
Mm-hmm.
how often tombstone removal occurs. I don't know if you
Yeah, we haven't tried that. We are in the process of trying this thing. So the first thing I wouldn't say mastered yet, but we are doing our field readiness on atomic batches, and that's where I got some of the metrics saying how bad is it or how good it is, because it looks all good on paper, but what happens under the hood for Cassandra? So we got through that. I think this year we may not face that specific tombstone issue because our deployments they'll be more non-delete heavy in many ways, but at some point we will. The biggest telco will upgrade to our next generation software, and that time they will ask for that.
Can you give any details of how you managed to move away from SSDs to SAS? Because
That seems radical, yeah.
yes.
Yeah. So I'm more than willing to talk after that. I think I need to wrap up right now. But thanks a lot for.
And we'll grab your next question.
Oh, sure.